So, good morning, all of you.
Good morning, sir.
Good morning, sir.
Yes. So, in our last class, we started the pointer. So, what we understand is pointer is one type of data type, and there are two types of representation. The first is how to declare a pointer, and second is how to operate with the pointer. So declaration of the pointer is as simple as the any type of data declaration. So I can declare an integer pointer like integer star IP. So this is basically the declaration of an integer pointer. Similarly, if we want to make a character, then ch or cp, this is the declaration of the character pointer. Okay. So in this way, for every data type, the standard data type, we also have a equivalent representation of the pointers. Okay. Float, we could have say fp, the float pointer, etc. etc. Okay. So this is all the declaration that we do at the beginning of your programming. Okay. Then there is an access. So the thing is something like this. It means let me just write a simple code that we have, say, integer a equals to 50, and then we have IP equals to % of a. So this basically means the address of variable a is assigned to the pointer variable IP. Okay. So in the physical memory, there will be a area where the A will be stored. So 50, and its base address, let's say 567.132. And then in the memory, we have another variable IP where this address, so this is basically 567.132. This address is available. Okay, so IP is basically a variable where I can store the base address of an integer. Okay, understand? So now how can I operate on these things? So there are two types of operations. One operator that we have already understand. So this is called the reference operator. What is the purpose of this reference operator? The operator basically returns the base address of a variable. Okay. So, and then we have also a dereferencing operator, which is also a star. So star is called the dereference. This is called the dereference operator. Okay. So now I can use, say, I can write some statement like I have also an integer b. So b is equals to star IP, say, +2. So what is the meaning of these things? The meaning is that there are three operators we are using. One is the assignment operator that we understand. Another is the addition operation with the integers. Okay. So in this case, the addition operation, it has a integer to its right. So this is 2. Then what is the another operand? So this is another operand, which is a IP. IP is not the integer. IP is basically the address. So the dereferencing is saying that whatever the address is stored in the IP, we refer to that element in the base address. So star P is basically dereference the address to a particular element. Understand? So in this case, it will be a 50. Clear? So I have, let me write it in the next page. So the statement B equals to star IP plus 2. So it is something like this. We have 2. Then this is the operand, which is called the dereference. And we have an argument as IP. Clear? Understand? So this is not the multiplication operation. This is the dereference. Sorry, dereference. So it implies that the element it returns basically star P, the star IP returns the element which is stored at the address pointed by IP. Okay. So if it is something like this, say 50 is this is the base address, say 37, what was the part? 567132. Okay. So say 567132, and then there is a IP is an integer pointer where 567132 is up. Okay. So now star P, what it does, it first refer to this IP. So where IP is there, what is the content in the IP is an address. Yes, and then it points to the element which is stored in the address of 56713. Understand? Get it?
Sir, can you double
Yes, sir.
the stored element?
Yes, repeat please your question.
Can you
In
double the stored element in B?
stored element in A or B?
Yes. Double the stored element in A.
Yes, you can do. So you just make these things IP 2 into star IP. Here. So if we write these things star IP, then it will perform the doubling of this part. Understand? Okay.
Okay, sir. Sir, star IP is first or the second part?
This star IP is the dereferencing operation. This star is the multiplication operation. Okay.
So star IP is the first. Then when star IP divided by 2 or star IP 2 divided by star IP.
Whatever the things you can do, you can do star IP divides by 2. Okay. Or 2 divides by star IP is the different things. One is the this 50 will be divided by 2. In this case, the 50 will be divided by 2, and in this case, 2 will be divided by 50. Understand? Clear?
Okay, sir.
No. So actually, try to understand that there are two symbols. Means these symbols is also used as a multiplication, and this symbol is also used for dereferencing. Okay. Then how the compiler will understand that which one shall I perform? That will be resolved by the operand. So if I write, say, integer a, then integer star IP, clear? And in some way I am writing a into, say, star IP. Okay. Then compiler will understand that this operation, it has an argument as an integer. Clear? And it has another argument which is also the dereferencing of the value. So it is also an integer or whatever the float it may be. So this operation is basically a multiplication. Understand? The compiler has this intelligence to resolve which symbol is used as a multiplication, which symbol is used for the dereferencing. Okay. So dereferencing is this is a binary operation when it is a multiplication. Okay. So I can understand that I have two arguments. One is the left, another is the right. So I shall treat this operation as a multiplication, whereas this is a unary when it is a dereferencing. So now I can understand that this is the operation which is a unary operation, and it is basically the dereferencing operation. Okay. Similarly, you will find that plus as a positive sign and the plus as an addition, and this is a positive. So they are having the same symbols, but compiler has the intelligence to understand, because this is an unary operation, this is a binary operation. Similarly, minus and the subtraction. So negation is basically unary operation, and subtraction is a binary operation. Understand? So depending on the arguments and the operation, we can segregate. We can easily distinguish that what the compiler will be performing. Okay. So there are three operations that we have so far understand in terms of a memory or address. Memory or address. So what is that? There is an indexing operation, which is you are familiar when you are studying the array. So indexing operation is binary operation. Okay. So it means one of the operations, so it looks something like this. One is the base address, or the left hand side of the index operation is the base address, and the right side of this index operation is a index or offset. Okay. So this operation is applying on that memory. So we must have one of the operation, or one of the operands should be a memory or the address. Okay. Similarly, we have a ampersand. Ampersand is basically called the referencing operation. Okay. So this is a unary operation. So this is a unary operation. Okay. So it looks something ampersand of A. That means the operation, this takes an variable and it returns the base address. Okay. So if I write say ampersand of A, where A is an integer, then it will return the base address of this integer, or the starting point of the integer. Okay. And similarly, we also have a dereferencing operation, which is a star. So this is a D operation. Okay. And this is also an unary operation. Okay. So what is the meaning of these things? It basically returns the element which is stored in that address. Okay. So in this case, where I can write, in this case, it looks like star IP, where IP is not the variable. So this is an address or pointer. Let it be a pointer. Okay. Understand? So this is binary, which has a base address. We have to specify the base address and the index. This is basically unary. We have the argument as a variable. This is the unary operation. We have the argument as a pointer. Understand? Get it? So they are basically, these two are basically almost look similar. So array, if I write say array 3, that means it is returning the fourth element in that. Understand? It is clear? You understand this part?
Yes, sir.
Okay. So now, if I write, say, star IP, okay, that means it also returns what it returns. It basically returns something like this: IP0 means the address which is stored at the base address that it returns. Understand? Get it? So this is basically the same. These two operation is almost equals to the same. Like this acts as a unary operation. This acts as a binary operation. Understand? So by default, IP is working like that. IP index 0. Okay. So by default, it is a 0 index. So it returns the element which is stored at that address. Okay. Understand?
Sir,
Yes, sir.
one thing I have to ask, sir, if we write int star IP, so sir, it is initially only dereferencing the variable IP. So what does that mean when we declare a pointer?
No, declaration is basically I am declaring that IP is a pointer variable. So as the program starts, so when we starts the program, so I have to define the data type like A, B, then IP. Clear? Understand? So I will use this variable. So doing these things means I am instructing the compiler to allocate space in the memory. Clear? IP. Understand? And also we instruct the compiler that this is an integer type, this may be a float, and this is a pointer. So I write integer, float, say IP, sorry, integer star. Integer star. Clear? So the purpose of the declaration is to make the variable available in my working space. Then I start the program. The purpose of this program is basically to use the value which is stored in the variables. So now I can make IP which is basically referring to this element. Understand? So that declaration, this star IP and this star IP are different. So this is used in the declaration part when I am attaching integer, say star IP. So this is basically the declaration which only allocates a space in the memory, and it says that this address is for the integer. Understand? Clear? And now I am working with the address. Now I am using this star as a operator.
So integer star IP creates a space for
Ah.
particular integer.
No, it does not create a space for the particular integer. It creates a space for the address of an integer. Understand? So I'll make these things more clear. So let me just first understand that there are three operations which are useful. The one is the index operation, here, which is applicable with the array. Then the referencing operation, which is applicable on the data variables, and another is the dereferencing operation, which is applicable on the pointer. Okay. So now just go to the slide. Oh. Okay. So what we have discussed is basically there are three operations. One is the index operation, then the referencing operation, and the dereferencing operation. So just make some more additional information. So it is a so if the index operation, a binary operation, the left side is basically a base address, and the right part is basically a offset. Okay? And this is a left to right association. Yeah. So left to right association in the sense, say if we have, say let us have an array, say 10, which looks something 5, 3, 1, say 0, say 4. How many? Let it be 5. Otherwise, I have to write so many elements. 1, 2, 3, 4, 5. Oh. So let it be 2. Okay. So there are 5 elements in the array. So now, so array, say 1, what does it means? What it returns?
Sir,
Sir,
3.
3.
3. Okay. So now if I write array, say 1 plus array say 2 means 1 or 2. What does it means? How it will be interpreted? So there are cascades of index operation. So there is a one index operation. There
Or
is
4.
another
Finally 4.
index. Okay. The thing is that there is basically some cascades of index operation, something like this, or whatever the parts. Clear. So if we have cascades of similar type of operation, then there is a rule that whether I have to evaluate the things from left to right, whether I have to evaluate the things from right to left. Okay. Now, in this case, it says that the evaluation should be left to right. So it will be the first base address array. Clear? Now it is looking for an index, but index is not available. So it again evaluates the second part. So this part it will evaluates. So there is an array and it looks for an index. And again, it does not find the index. It finds 1 plus there is an array, which is a 1. Okay. So this result will be given to the second hierarchy. So this result is basically 3. So this is basically becomes of 3 plus 1, 4. And array index 4 is basically what? Array index 4 is 4. And now I have returned the element as a 4. Understand? Get it? So what it returns? It returns 2. It returns 3. So this is array 1. Okay. So it returns 3, then 3 plus 1, 4. So this is the array 4. It returns 4. So now again array 4 appears, then it returns the element 4. Understand? Okay. So it is basically I am evaluating the things from left to right. Understand? Okay. Is that okay?
Yes, sir.
Yes. Okay. So the meaning of this, the right hand side says that the meaning of this address array index I is basically I am making an offset of I, and then I am retrieving the element from the array. Okay. So one part is the integer. So keep in mind that the second item, the second operand should be always an integer. You cannot write a floating point as a second operand. Okay. The first operand is a base address. The second operand is basically a integer. Okay. And it is also maybe useful that the precedence of this array index operation is higher than the star and the referencing and the dereferencing operation. Understand? So if I have 2 operation cascade in this part, then the index operation will be executed first, then the other star operations or the dereference will be executed.
So what is offset?
Offset is basically the starting point, and then we move either to its left, like array. This is the base address, okay, which is stored here. Okay, so if we write these things in the memory, then 2 is there, then 3 is there, 1, 0, and 4. Okay. So how we have organized these things? It is only organized by the base address. And then we also have a offset. Offset means either I have to move, this is the positive offset. Say if I write 2, then I am moving the 0th, 1, and 2. Okay. So it will return array 2. Array 2 will return the element 1. Okay. So offset 0. This is the offset of 0. This is the offset of 1. This is the offset of 2. Okay. Understand? Similarly, there may be a negative part of the cells, but in array we always use the positive part of the cells. Okay. Then there is a reference operation. The reference operation is a unary operation that we already discussed. So one of the part is that the reference operation always have a data type. It may be an integer, it may be a float, it may be a character, even it may be a pointer also. So I can, if I write the statement something like this, say there is an integer IP here, and then just I'm writing these things. I will discuss these things in detail. So what is the meaning of these things? So I can store IPP, which can be something like this. Understand? So what is the meaning of these things? Integer, this is already a pointer, and this is called the pointer to a pointer. Yes. So the operator ampersand of whatever the things, we say that this is a data type. And whenever I am talking this is a data type, then it can be a primitive data type like integer, character, or it may be a pointer type data also. So it may be also a integer pointer, character pointer, etc. Understand? Yeah. So I can also store the address of a pointer to another variable. So which is a integer pointer to a pointer. Okay. So just to keep these things understanding, this is an example. But the thing is that this referencing operation have an argument which is a data type. Okay.
Sir, so basically double star is actually returning the base address of pointer only, no?
Double star is basically returning the, means it is a hierarchy. Like I'll show you. I'll show these things in after some slides. Okay. And then we have the dereferencing. The dereferencing is basically the opposite of the referencing. So whenever I have the variable and their address, now we have the address and the variables. Understand? Okay. And keep in mind that this is the another way. This is the right to left association, and the index operation is basically the left to right association. Okay. So this is some example. If I work with this example, let us have an array which is size of 3, and the element is 10, 11, and 12, and I have an integer pointer declaration. Okay. So what is the means in the first line, what will be the value of this ANS? ANS will basically what it does.
11.
It is basically first it refers to the base address count. Okay, and then it applies the index. Okay, so it is basically there is a count is the base address where we have 10, 11, and 12. Okay. So count plus the offset of 1, which means, so I am in the offset of 0, I am in the offset of 1, I am in the offset of 2. So count 1 will return the element 11. Is it? Understand? Is that clear?
Yes, sir.
Then what is the second statement, how it works? So it is basically, what do we mean by the star of count? Star of count means it is similar to the operation count index of 0, because star of count is basically returns, this is the base address. So count is an address, and I am referring the I am dereferencing the address. So it will return the content which is stored in the address count. Understand? Clear? Is that clear? So
Yes, sir.
count is not a integer, it is basically an address. Address, and now star of count is the dereferencing of the address. Okay, understand? So now think what is the meaning of count plus ones and whole star. So count plus 1 whole star. Yeah. So what it does? So it basically have a parenthesis. So there is a dereferencing operation which will take an address, and now this address has an offset. Address does an offset operation which is count and 1. So this is an offset operation. This is a dereferencing operation. Understand? Get it? So what is the meaning of these things? We have the count here. We have an offset operation of 1, and then it returns the element which is stored in that address. Get it?
Yes, sir. Say it will also return sir 11.
It returns the element 11. But how it returns? It is basically the count is the base address, and then I have this plus is not the addition operation. It is not count plus 1. Yeah, because as we do the operation, as we work with the address, then we call this addition of symbol plus as a index operation. Offset operation. Understand? We don't call these things as a addition operation. Okay. So this is an offset operation of 1, and then the address moves to the offset of 1, and now we are making the dereferencing of this address. Okay. Okay. Get this point?
Yes, sir.
Okay. So the thing is that in the first two statement, these are compatible. Means I am at the right hand side of the assignment operation. There is an integer which is assigned to a variable integer. So ANS is the integer, and right hand side also gives me a integer. Understand? In the third and fourth, you find that what we are doing. We are basically assigning the base address to a variable. Okay. So IP is now becomes a variable. So now what I am doing, now there is an IP which is a variable and its type is address or pointer. Okay, or pointer. So now I am assigning count to the IP. The meaning is that count is basically a base address, and then this is compatible assignment. The base address is assigned to a variable which can hold a address. So IP, it can hold a address type of data. Address type of data. Understand? Okay. So a base address is now available in a variable which is a pointer. Understand? Get it? So now the thing is that this pointer can be reassigned. This pointer can be reassigned. Means previously what we said that once we declare an array, the array cannot be reassigned. So array is basically a static type of memory allocation. But I can reassign the pointer with updation. Means I can make a count plus 1. That means in this case it is basically, say it is 5311000. Then this will be the next base address of the part. Understand? Okay. So this statement says that the pointer variables can be reassigned. Means it is not a static type of allocation. I can dynamically change the content of a point. Okay. Do you get this point?
Yes, sir.
Okay. And these are basically the referencing. So again, ANS is basically what ANS does. ANS is basically an integer type of data. Understand? Now I am assigning the base address of the ANS to the pointer. Okay. Similarly, count 1. So this is basically, there are two operands. One is the assignment operation, say IP count of 1. So one is basically the index operation and another is the reference operation. So we find that index operation is the higher precedence over the reference operation. So in this case, this will be executed first, the index. Here, operation will be executed first. So it will come to this point, the element 11, it comes. Then it makes a dereference. So it returns the address of this element. Understand? Clear? Is that clear? So
Yes, sir.
count 1 is now basically this element which is available in this cell. And now we are dereferencing. We are returning the address of this cell. Understand? Clear? Okay. So, and again, this is basically the dereferencing. So it is similar to this operation. I am now pointing to the element which is stored in the address of IP. Okay? Star IP is basically performs the same thing. Okay? Similarly, IP 0 is performing the same things. Understand? IP 0 means we just now think that IP is playing a array where the base address is IP. Yeah. So it is very interesting to understand. Let I have a counter. Say this is an array count. That means this is a static allocation where we have some element. Let it be say 5 or 7, whatever the things. And I have an integer IP star. And I assign IP, which is a ampersand count, something like this. So now this is also assigning to the same point. IP is also pointing to the base address. Count is also pointing to the base address. Okay? But I cannot modify the count. I cannot modify the count in. I cannot update the count. But I can update the IP. I can update IP to say IP plus 2. That means it goes to the offset of 0, 1, 2. Now 0, 1, 2. Now IP is pointing here. Okay. Understand? Get it? Is that clear?
Yes, sir.
Oh.
Sir, but one thing I have to ask. Sir, count is already an address. So, sir, if we apply ampersand address, so, sir, will it not be invalid?
Sorry. It is not ampersand. This is only count. Yes. Is only count. Okay. Achha. So now think that I am writing IP, say IP2. Then what does it mean? It means that I have instruct the compiler to interpret this is an array. This is an array where the base address is IP. Here. And IP2 will be indexing. So this is the now this will act as an index 0, 1, and 2. So IP2 will return the element which will be available in this. IP2 will return the element which will be available here. Understand? Clear? I have defined an array. Here, I have already defined the array here at this point, but I cannot dynamically move the array starting point by using the count. But if I assign the count to an integer pointer, then my purpose will be solved. I can dynamically move the starting point of the array by changing the value in the IP integer pointer. Understand?
So, sir, this IP2 will not return the element, no, it will return the address of that.
IP2 will return the address. This will return the element. This will return the address. Understand?
Sir, but one thing, sir, IP is not an array, it is a pointer. So, sir, how are we writing IP to, like, couldn't
This
understand.
one, this statement.
Yes, sir.
So this statement interprets that what is the statement says. This operation needs a address. So one is the argument is address, and another is the integer. Clear? Now this is compatible. Means I need not to have a static allocation for the first argument. I need an address for the first argument of this operation. Understand? So I provide an address to the operand as a first operand, and I provide a integer as the second operand. Then it works fine. Clear? So
Yes.
this operation does not restrict that you must have a static address as your first operand. It only says you have an address as your first operand. Clear? But now you as a programmer, you can have some facilities. Means if we declare IP, then I can move the starting point of an array by changing the value in the IP. Understand? Clear? So this is a right statement. There is no problem in writing IP2 because the operation requires two arguments. One is the address, another is the integer. Okay. Is that clear?
Yes, sir.
Okay, very good. So so far we have just gone through some operation, which is basically indexing operation. Means I am fetching. I am either referring the address, or I am either referring the element which is stored in the address. Understand? Okay. What is the time? I have only 5 minutes to go. Okay. So we can stop here. In the next class will be on the Monday. Okay. And when is your exam? Achha, Monday is the mid-sem. You are starting the mid-sem from Monday to Friday. Okay. Hello.
Okay, sir.
So there is a CA2 which is scheduled from the next Monday to Friday. Understand? So we don't have the class in that period. Our next class will be after your mid-sem. Understand?
Okay, sir.
So Friday we will not having any class. We drop the class and you take your preparation. And the syllabus of the this class will be communicated over the mail. We will have a common meeting on 10th, and then we'll communicate the syllabus of this exam. Okay.
Oh, okay, sir.
Sir, will we have today's lab
স্যার
class or
পয়েন্টার
not?
কি থাকতে পারে?
Huh? Yes, but I'm not getting the questions.
Sir, today lab class will be there or not?
Yes, lab will be there. Today, up to today, we will have the classes. Okay. So Friday class, we drop the Friday class. And today we'll have the lab from 3 o'clock. Okay.
Okay,
স্যার
sir.
পয়েন্টার কি সিলেবাসে থাকতে পারে?
Pointer, I'm not sure. May not be, pointer may not be in the syllabus. Okay. But we have not completed the pointer. So we can exclude the pointer from the syllabus. Understand?
ওকে স্যার।
Oh. Okay.
Sir, exam will be written or quiz?
No, this time your exam will be paper and pen. So you have to scan and upload your answer script. Understand? Okay.
Okay, sir. Thank you, sir.
Okay,
থ্যাংক ইউ
so-
স্যার।
Thank you, sir.
Thank you.